So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we'll be learning about the brief history, the brief study of case histories in the engineering constructions. So if you remember in the previous lecture, we have discussed about what is the importance of geology in the civil engineering point of view. So how geology is important in the civil engineering point of view, what are the things which we can understand to avoid the construction failures in the history. So here we'll be we will see the case studies, the different construction, the famous constructions in the civil engineering in the history. What are the famous constructions that we will be understanding, that we will see here, and then we will understand the type of case histories here. So before this, let us understand about the brief study of the case history in the engineering construction. So what is a case history means? As we know, the civil engineering is basically, it is about the construction field. So there are different kinds of construction. We use it by using the earth materials. So geology is the study of earth materials, like the different kinds of materials which we study about the earth surface features. So that earth materials, we use it in the construction field. So there are the famous constructions, there are few famous construction, there are few case histories which are as on today, they are totally standing as a stable structure, and they are durable too because of the knowing about the geology of that such area and geology of that rock or the geology of that area or site. So in this first one, we will see the Burj Khalifa, which is in the Dubai. We call it as the tallest skyscraper. So it's a tallest skyscraper which is about the height of 8 to 828 meters. So it's a very huge structure in the history. We call it as the tallest building in the world, which is the tallest skyscraper, which will be touching the sky, and it is a very tall building. Construction started on 2024 and it ended 2010. So these years they have just struggled, they have just tried to mitigate this kind of the kind of soil where whatever was present over there, because Burj Khalifa, as we know, it is in the Dubai, and the conditions over there is very much dry conditions. The soil what we have is a sandy soil, which is very difficult to handle in the construction field, and making such a huge building, it's a huge challenge to a civil engineer. But they have tried, and they are successful with this kind of skyscraper. So structure is a global icon of the architectural and engineering innovation. So it's the tallest skyscraper to top of the antenna, 829.8 meters, so around 2,722 feet. So previously the Wills, the formerly Sears, the tower, 527 meters or 1,729 feet, building with the most floors. So it has a floors of 163. So it's like it has a floor of 163 floors. It has previously the World Trade Center, which was having 110. Now this is the latest one. Before that, World Trade Center was the tallest building. Now this is the latest one, which is having the floor of 163. So this is the challenge. What was the challenge to a civil engineer over there is extreme heat in the Dubai, and it required the development of a special concrete mix and the advanced cooling techniques during the construction. So it required a special concrete for the advanced cooling effect and during the construction, and it was built on weak weathered sandstone with a low bearing capacity. It was built on the weak stone, it was built on the weathered sandstone and with a low bearing capacity. So required the lightweight but strong concrete mixed for the extreme heights. So this was the challenge given to the civil engineer, but still they are success to make this. So this is the figure related to this Burj Khalifa. As you can see, it's a skyscraper. This is how the tallest building it looks like. And what was the innovation over here is unique Y-shaped floor. They have made a unique Y-shaped floor to plan for the stability, to make the structure stable. They have planned for a Y-shaped floor planning. So why they have done this floor planning? Because they have before only they have studied the geology of that such area. That's why this building was successful. High strength reinforced concrete, advanced wind tunneling testing, and everything they have done before they go for this construction. And what was the engineering solutions for it is, so it is used, they have used 192 deep piles. Deep piles means they have just modified they have stabilized the soil, because it's a sandstone. The soil will be made of sand, so soil was sandy soil. So what they have done is they have used the 192 piles. Piles means they have just made a small piles so that the structure should stand stable, each of 50 meters into the ground. So one pile is like this. So they have made a pile with a difference of 50 meters. Okay, 50 meters on the ground. So second pile. So like that they have made 192 piles to stand the structure. So concrete mix design included high performance material C80 to C100. So wind tunnel testing to produce the structural oscillations, and deep pile foundation ensure the stability on the weak rock. Okay, advanced concrete mixes improves the structural strength. So this was the solution given to this structure. So next once we see the second the famous structure here is Three Gorges Dam. So this is the dam which is known as for the hydroelectric power project, and this dam is located in the China and completed in 2012. So the dam is the largest hydroelectric project in the world, spanning the Yangtze River, and the challenges to make this dam was displacement of 1.3 million people. So while construction of this dam, there was a huge challenge to the civil engineers, huge challenge to the geologists, that 1.3 million people are going to be displaced, or that was the environmental concern over there. So innovation is advanced flood control measures, a ship lift system for the navigation. So they have made a ship lift system over this dam for the navigation purpose, balancing the developmental needs with the environmental social impacts. So this was the dam which was called as Three Gorges Dam, which is famous for the hydroelectric power station, which is in China. Next, what we have is Millau Viaduct, France. So this is also called a famous construction in the history, in the case study in the history, which was the tallest bridge. It is the tallest bridge. And the overview, if you see, it is opened in 2004. And is the tallest bridge in the world, with pylons rising up to 343 meters. And challenges are building over the Tarn River Valley with minimum environmental disruption. This was the challenges given to it. And innovation, when you talk about use of high strength steel, lightweight materials for the deck and the construction, along with the advanced geotechnical studies. So effective use of technology to overcome the geographical constraints. So this was the bridge we called as Millau Viaduct, France. So it has a tallest bridge, which has a tall bridge in the world, and this is the famous construction and successful construction in the history. Now we have this tunnel, which is UK, France. So this is the huge underwater tunnel. Making an underwater tunnel, it's a huge challenge to the engineers, and they completed in 1994. The challenge was the tunnel connects the UK and the France through the 50.5 kilometers rail tunnel beneath the English Channel. So it connects this tunnel connects the UK and France through the 50.5 kilometer rail tunnel beneath the English Channel. So what are the challenges over this to the civil engineers? If you see, the challenges is managing the water seepage, because if it is an underground tunnel, the major problem here will come is like the seepage problem. So to manage the seepage problem, maintaining the alignment between the construction from the both sides, it's very difficult challenge. It was very difficult task, but still it was a successful history in the world. So innovations, tunnel boring machines they have used, and they have used a robust water sealing techniques they have used for the innovation purpose. Importance of international collaboration, robust project, and the management. Now Sydney Opera House. Sydney Opera House is also one of the famous construction here, which we call it as architectural landmark. It's an architectural landmark. So overview, it was completed in 1973. It's a UNESCO World Heritage site known for the unique shell-like design. So it has a shell-like design, and it's UNESCO World Heritage Site. We call it as UNESCO World Heritage Site. Challenges given to this kind of construction was complex geometry of the roof, limited construction technology at this time. So complex geometry of a roof with a limited construction and the technology at this time. Innovations: precast concrete panels and the computer-aided design, a groundbreaking tool for its time. So groundbreaking tools for its time, patience in initiative design, and the significance of the aesthetics in engineering. Now next is Gotthard Base Tunnel. So this is also one of the famous construction which is in the Switzerland, and the challenges given to this kind of tunnel was, this is the world longest. It was the world longest tunnel, deepest tunnel, rail tunnel, and running around 57 kilometers. 57 kilometers beneath the Swiss Alps. So this was a huge channel to a civil engineer to construct a deepest rail tunnel with a 57 kilometers beneath the Swiss Alps. Okay, and the tunnel constructions involved the overcoming and geological uncertainties and difficult rock conditions, geological conditions it occur in between, and the tunneling techniques. The use of tunnels, boring machines they have used, allowed the tunnels to be excavated with high precision, reducing the impact on the environment and minimizing the risk. So this is how the Gotthard tunnel base was. This is the figure about it. In the Switzerland, it was maintained. And if you're talking about the geological surprises to this tunnel, engineers had to deal with the unexpected geological formations. So unexpected geological formation may happen, which led to the changes in the design during the construction. So the challenge which is given to the civil engineer, unexpected kind of geological formation, if it happens, then again they have to change the design during the construction work. Time and the budget management, the project took over 17 years. So it took 17 years to complete, highlighting the need for the meticulous planning, risk management, and the adaptability, and when working with the unpredictable conditions. So these are the references which you can just go through to find out the more information about the different case studies, case histories about the constructions in the civil. These are a few points, few kind of information, few examples I have given you. So if you want more information, you can just go through these references to find out the more content about it. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.